This is the fifth and final question of the Physics 102 final in spring 2018. Okay, we are given a cylindrical resistor. It has a diameter D and resistance R. Now, what's the resistance of an object, of a cylindrical object? Its resistivity of the material. Resistance is proportional to the length and inversely proportional to the cross-sectional area. The radius is diameter divided by 2 square. So what's rho? Rho is R divided by L pi d square over 4. So pi over 4 R over L d square is the answer we are asked to find. Find the magnetic field magnitude and direction inside the resistor. Well, the current is uniformly distributed on the inside. So if I take a cylindrical cross-section, an Amperian loop of radius R, what would be the current inside this Amperian loop? The current inside this Amperian loop would be proportional to the area of that Amperian loop, but the total area is pi over d 2 square times the current. So pi is cancelled. I have 4 r squared divided by d squared times I. And Ampere's law tells me that mu 0 times I in must be B dot dl. And with cylindrical symmetry, this is just going to give me 2 pi r times B. Right? So B magnitude will be mu 0 over 2 pi r times 4 r square over d square times I. R is cancelled. So this is going to be 2 mu 0 over pi d square r times I. That's the magnitude. How about the direction? Well, if the current is running to the right by our right-hand rule, B must be circulating around that cylinder. Find the electric field, magnitude and direction inside the resistor. Now this is somewhat a trick question. What's the current density vector? I divided by the area. What's the electric field? Well, I know the following. Rho times the electric field must give me, rho times J must give me the electric field. So this is going to be rho times I over pi d square over 4. And for rho, I already have the answer. Pi over 4 r over L d squares cancel, pi over 4's cancel. That gives me I r over L, which kind of makes sense because the voltage across the resistor is IR. If I divide it by the length of this object, I should find the electric field on the inside. How about part D? Find the pointing vector, magnitude and direction on the curved surface of the resistor. So here's what the situation looks like. Electric field is to the right and magnetic field is circulating. So what was the pointing vector? 1 over mu 0 V cross E. No, E cross B. Now E cross B is at each point. E is into the page, B is circulating like that. So E cross B is apparently into the conductor. So that gives me the direction. How about the magnitude? S magnitude is 1 over mu 0. E is I R over L. B at the center, I'm sorry, at the surface is 2 mu 0 over pi d square times r is d over 2 at the surface times I. 2 mu zeros cancel. 1 power of d cancels. So this is I square r divided by pi d times L. It's a curious result. Find the flux of the Poynting vector over the surface of the cylinder. Over the surface of the cylinder, all that and Poynting vector is constant, so this is basically the side area of the cylinder, which will be pi times, this is d over 2. So the lateral area of the cylinder is pi times d over 2. 2 pi times d over 2 is the circumference of the circle. The length is L. L times S magnitude. These cancel. This is I square over R. Now what's I square over R? It's the energy dissipated in the resistor per unit time. So this is essentially, it's as if you're sucking all this energy from vacuum. So you have to be careful considering this energy flow and Poynting vector, which is a really nice way to see what the Poynting vector does.